So we've been talking about this relationship between the inputs and outputs. Now let's talk a little bit about the domain and the range. So the set of all possible values of the independent variable, or the input in a function, is called the domain of the function, and the resulting set of possible values of the dependent variable, or the output, is called the range. So the domain and range are sets of numbers or objects, groups of things, and what connects these is the function or the relation itself. In our first example, where we were connecting fruit or berries with their colors, the inputs we were talking about were over here, and those were the domain. So apple, strawberry, and lemon were the domain for that problem. The range were all the things over here. So red, green, and yellow was the range. Even though that previous relationship was not a function, we can still talk about the domain or range. Now in the next example, remember we had numbers. So the inputs were 2, 4, and 6. And so to signify that, I'm going to put in curly brackets here. The curly brackets mean a set, 2, 4, and 6. If I ever see the same number twice in either one of these sets, when I list it out here, I only have to put it down once. The range was the 3, 7, and 5. And so there it is. I've put it in curly brackets also. So the domain is the set of all inputs, or the set of all values for the input, or the independent variable, and the range is the set of all values for the output, or the set of values for the dependent variable. Now when we go to this table, it's going to be even easier because remember our first column was all our inputs, so the domain is just the set of all those objects, and again I've gone ahead and used the curly brackets here, meaning the set. The outputs were 18, 19, and 29, and notice even though 18 appeared here twice, when I write it down in the range, I only need to list it once, because all we're saying is these are the types of things that are there. I'm not actually listing every single one of them. If 18 appears more than once, I just have to write it down once. Now, where things get a little dicey here is when we start talking about functions that are defined by graphs. The domain, remember, is the set of all inputs, and the set of all inputs come from the horizontal axis, and I'm going to put an X there. The range is going to correspond to the y-axis, or vertical. And so when we talk about domain and range now, we want to know about the vertical and horizontal extent of this particular graph. If I take a look at how this graph runs, remember we've got arrows down here, it runs horizontally infinitely far. And so to signify that, I'm going to use interval notation here, and I'm going to write minus infinity to plus infinity. The minus infinity means it goes infinitely far to the left. The positive infinity means it goes infinitely far to the right. Now the range is how it extends up and down. And certainly because these arrows are going down, we know it goes infinitely far down, so that's where that minus infinity came from. But it doesn't continue to go infinitely far up. In fact, it stops at 4, and it includes 4, and sometimes you'll see a little dot there to show that. So in interval notation, I'm going to write minus infinity to 4, because downwards it goes infinitely far, but going up it stops at 4 and it includes 4. Remember, brackets means that you include the point. Parentheses means you don't include the point. And certainly you can't include minus infinity because we don't even know where that is. So another way we could define a function is using a formula. And right now, don't worry about this f of x here. You can just think of this as being y equals 1 divided by x minus 2. Now, on this function, the domain actually consists of two parts here. Minus infinity to 2 and also 2 to infinity. What you'll notice is this includes everything but the number 2. And the reason for that is if I go ahead and put 2 in place of x here, I get 1 divided by 2 minus 2 or 1 divided by 0, well, that doesn't make any sense. And so for a fraction like this, by not including the 2, that means we're not getting divided by 0, but any other number works perfectly fine. If I put a 3 in here, 1 divided by 3 minus 2 is just 1 divided by 1, which is 1. So I'm thinking in that case about possible inputs. I'm putting things in place of x. Now the range is a little bit different. Now the range is what comes out of the function. If I think about this, fractions, well, I can get positive or negative numbers out of that by making sure one of the pieces of the fraction is either positive or negative. And for instance, if I put 3, 4, 5, 6 here, I'm going to get out 1 divided by a positive, which is positive. So I see things that are positive by writing 0 to infinity. And if I put in numbers like 0, -1, -2, this bottom becomes negative, and so I get out all sorts of different negative numbers. So you see negative infinity to 0. What we're missing here is 0. And the reason for that is when you have a function or a fraction, the only way that can be 0 is if the top's 0. But this top is never going to be 0. It's always 1. So there's no way we can get an output of 0, because to do that it would have to be 0 divided by something, and in fact we have 1 divided by something. So when I write out my range, it's going to consist of two pieces. We can get out negative values, we can get out positive values, but we can't get out 0. So that's why you don't see a bracket on either one of those pieces. So unless otherwise stated, we're going to assume that the domain of all functions defined by an equation is the largest set of real numbers that are meaningful replacements for the independent variable or the input. Now, when we start talking about problems involving profit, revenue, and cost, we may modify that because some of those applications, negative dollars don't make any sense. And so we may throw those things out. Or negative values for production don't make any sense. All right, so now let's go ahead and look at another equation, and let's try and figure out what the domain and range is for that. And the way we're going to do this is we're going to take an equation, so y equals square root of x minus 1, and we're going to see if this defines a function of x. When you see function of x there, what that means is those are our input, our independent variable, and we need to ensure that each input corresponds to exactly one output. So each value of x corresponds to exactly one value of y. So to check this, what I've gone ahead and done is I've listed some values for x here. This isn't exhaustive, it's just some possibilities. And now let's go ahead and find out what are the corresponding y values. First thing, let's take a look at 0. When I put 0 into square root of x minus 1, I get square root of 0 minus 1. That's square root of a negative number. I can't do that. So to signify that, down here I've put UND for meaning undefined. Now some of you that are a little bit sharper will say, oh, that's a complex number. But we're only talking about real numbers in this particular thing because we're thinking about graphs. So for real numbers, that doesn't make any sense. If I put 1 in here, I get square root of 1 minus 1. Square root of 0 is 0. If I put a 2 in here, I get square root of 2 minus 1, which is square root of 1, which is 1. And if I go ahead and I put in 3 here, I get square root of 3 minus 1, or square root of 2, and that is approximately 1.4. Now, notice, each time I put in a number, I got out a number or I got out nothing at all. So this is kind of telling us two things. First of all, because we got undefined here, 0 isn't a part of the domain. But every other number that I put in here, things that were either 1 or bigger than 1, when I put those numbers in, I got out only one output. As long as I restrict myself to things that are 1 or greater, that's telling me what the domain is. What I get out are things 0 or greater, that's telling me what the range is. So in looking at this, I'm thinking that my domain is numbers 1 and larger, and my range is numbers 0 and larger. And all I'm doing is I'm just kind of thinking about what's going on. What is the domain of y equals square root of x minus 1? Well, we've got kind of an idea of it, but to really get a good idea, let's take a look at the graph. So here is the graph of y equals square root of x minus 1, and you'll notice that it starts at 1 and moves to the right. So that defines the horizontal extent, and so my domain is 1 to infinity, and it includes 1, so I put a bracket on the left-hand side. Now, at the same time, the vertical extent starts at 0 and goes up. So that tells me that the range of this is 0 to infinity, and because it includes 0, we put a bracket there. So that gives me my domain and range. So you can think a lot of times about what the domain and range is simply from looking at the formula, but the best way to do it is to go ahead and look at the graph, see how things go side to side and up and down, and then use that to get the interval notation for the domain and range.